Hi friends, welcome back to another video, and today I am going to continue the how to make a video game in Unity series. So if you haven't checked out the first video, go check it out. Top right corner video, check it out, finish it till the end and come back to this one real quick. So after you've done all that, you can press new, create a new project. You name it whatever you like. I'm going to name it a video how to make a video game because I think it's self-explanatory. And in the template, you can choose a 3D template. And since I already have a project called How to Make a Video Game, they are giving out an error saying the path already exists. But for you, that won't be the option. So press create, and then a Unity scene will be launched up. It will take quite a bit of time, so you'll have to wait. I've already launched my scene here, so let's get right in the video. Now, if you've watched my last video, you know that you know how to navigate around the scene, orbit around objects and all that. So just you can revise it a bit again, and this is what you will first see in the scene. It looks really bland and not very nice, so let's make it look nice. Now what we are going to have as the finished result after all the series will be a really cool replica of Geometry Dash, but you will be able to switch between 3D and 2D. Now ain't that cool? So let's get right into it. At first, to be organized, we will go in the project tab down here and right click here and go to create a folder, name it scripts, and control D for duplicating, F2 for rename, I think every one of us know that, and name this one prefabs. Now name this one other stuff for the music and audio and all of that. So now first let's get right in the video. So at first we're going to select the main camera, and in the inspector tab we're going to change this from skybox to solid color and change the color from this grayish blue to a bright red. Just get a bright red, something like that. Perfect. Now that looks very attractive and catching, so that is nice. Now also in the main camera, in this projection tab or sub tab, you can choose from perspective. You can switch to orthographic. That will make your main camera make things look like 2D for some reason. And let's just try it out. So go in the hierarchy, right click and make a 3D object called a cube, and F2 to rename it to a platform. And I'm going to tell you what it all does in a matter of seconds. And what you can do right now is scale it up by pressing R, of course, to get the scale gizmos. And now you can see our cube isn't really coming in the camera. For that you can just take it in. You can just see where the camera is pointing at, like in my case it's pointing there, and for some reason my platform is right there. So before you start doing anything, you can just in the inspector, in the transform, right click the transform and reset. Now you can see we have the cube in our main camera. Yay! Now let's just press R to get the scaling gizmos up and scale this up to make the platform on which our player will move around. Yep. Now just place this right at the bottom there. Nice. Now we can create another 3D object called a cube and rename it to player. This will be our player, aka you. reset the transform of this as well, and we're going to change the color of it so it stands out from the platform. So for that, go in prefabs, create, and material. Name this one player material for now. Material, and change it to a bright blue. Now that stands out quite a bit. Now we are just doing this in a very beta kind of form, if you know what I mean. So later in the video we are going to use a web app called Adobe Colors to get some more colors and make it really beautiful. So we are going to do that later, of course. For now, let's just go to our platform, add a component, add a rigid body, and check the use gravity. So it's by default it's on, just turn it off so that our platform doesn't fall down. We don't want it to do that, but we do want the player to fall down, so just add a rigid body and don't change anything in it. Now if we play the game, you can see that the platform falls down because of the the player's rigid body. So for that, what we are going to do is we are going to remove the rigid body from the platform. Now if we play the game, you can see it rests there. Yay! Now we are going to add a script. Let's start coding. So go in the player, add a component, and type a name for your script. So this is going to be a player movement script. So player movement, that's the right spelling, yep. And this should create and add a new script. So what we are going to do in here is detect for a mouse click, and if there is a mouse click, we are going to make this player jump in the air. So that will be nice. And now let's just go in the script real quick. For me, it is Visual Studio, the editor for the script. If you want to change and go to another editor, you can just go to Edit, Preferences, External Tools, and there you can set your script editor. Mine is Visual Studio 2019. You can set anything like MonoDevelop or Notepad. I think for Windows, by default it's MonoDevelop. So that's just nice. And now I know this is complicated, but bear with me, you will have so much fun with coding in Unity. Let's start. First, I'm going to explain you all of these and what they do, why are they here even. I could write them ourselves actually. Anyway, so let me just tell you about it. So these two using are not really required in a lot of situations. So delete them right now, but don't delete this one, or else your script will probably get deleted. So you don't delete this one. Now what is this? Let's start. This is void is a function that Unity gives you for buttons or things. You'll get to know later. So there are by default some code words like start or update that if you write a void with that name, it will have a specific function. So like the start is called at the very start of the game when you play it. So we'll just test that out, write some debug.logs. If you do not know what debug.log is, it's basically it will print a message that the message will be inside these curly brackets, no, not curly brackets, commas, inverted commas, and that message will be printed in the console here. So let's just try that. So we are going to write it works, and don't forget to add a semicolon after every line. So just going to Control S to save that, and now let's go in Unity and try it out. So if we start the game, we can see here it prints in the console it works. That's great. Now for the next function, the update function. I'm going to delete this real quick, and now let's get on to the update function. Now this is, as it's written here, is called every time a frame changes, or once per frame. So for example, you write a debug.log here, debug.log. So I'm going to write it works again, and if you save that and go to Unity, start this, you can see that it's only printing one time, unlike it's set here that it will be called every frame. So there should be a lot of it works in the console, and sure there are literally 999 plus it works. So that is every frame, one it works for every frame. That is just amazing. So this function is really handy. So yep, I'm just going to clear that so it doesn't pile up, and going to the editor now. Now going to delete this and actually get on started with our coding for the player movement. Now we want the player to jump when we hit the left mouse button. But before that, we also need the player to move right, because in Geometry Dash, if you've played it, the player by default moves right, and you have to press the or tap the screen to make it jump. So first we are going to make it go right. So going to get the scale up gizmos and going to make this a whole lot big, this platform, so that our player has a lot of area to move. So yeah, and also just check that your player is right on top of it. If it's not, it may fall off the edge. So just make sure it is always on the platform. Or if you can't do that for some reason, just why these gizmos coming up? Oh, okay, because they're there. So scale it up like that so that your cube definitely won't fall off. Check. You can see that your cube definitely won't fall off now. So that is cool. And now let's get on with the coding. Now we want the player to move to the right. That's easy to do. In the void update, before that, we can just make some lines here and write public. Now public, for it being available to us in the inspector tab. If we set it to private, it will only be available here and we can use it only here, and we also won't be able to reference it, so it will be difficult for us. So we always write public most of the time. Public, and now we are going to write the type of what we want to reference. So here in this case we want to move this player. For that, rigid body is used for a lot of things, even for adding some force in a direction. So just write a rigid body, public rigid body. I'm going to name it RB here. You can name it anything. Even you can name it rigid body. Now see what I did there? I capitalized the B but not the R. That's because the first letter of the first word, one sec, the first letter of the first word of your name, of the name of the public, there are a lot of offs here. So just of that, again off. So you get the point. So rigid body. Better than that, most people and most YouTubers also write RB because it's easy to reference. Now in the update function, we're just going to write RB dot to get all the components in the rigid body. So RB dot and then mass, drag, we can change all of that. That's why coding is really good. So RB dot add force, and then add some brackets and write now you have to write in the force, how much force in which direction. So this bracket add force takes three parameters: x, y and z components. But if you have referenced a 2D rigid body, then it will take only two parameters. But since we are making a 3D and 2D game, it will be a 3D game. So yeah, so this is going to take three parameters. So let's just so we are going to need to put it in the right. So let's just see that the right is x. You can see it changes in real time. So we need to add force in the x direction. So here we can also write a public float. Now we are writing public for variables here. Variables, what are variables? Variables are types of storage in online software and all that. So you can write public and then float. Float is used for text and a lot of text mostly. Then string is also used for text. Int is used for integers and etc. There will be a lot of variable types and I'm going to explain them later in the videos or later in the series. For now, just write float, which is for mostly for text, and this is going to be our speed at which the player goes. Now we aren't setting the speed here, but once we save the script here in the player, we are going to have a little lower the script, this thing. We are going to have a set variable kind of thing. I'll just show you. So x is the first, x, y, z, it goes like that. So we want to add direction in the x, so speed, and now whatever we input as the speed, maybe 1, 2, 3, 10, etc., will be added in the x direction. Now we don't want to add anything in the y or the z, so 0, 0, and after that don't forget to add a semicolon. That ends the line. Now let's save it, and I'm also adding this command in the update function, as it will happen every frame, because it will then get faster and more difficult for the player to play over time. So just save that, Control S, save that, go to Unity, and here you can see we have two extra components we can reference. One, we can drag and drop the rigid body in this RB as I showed you here. And the second is the speed, where we can add 1 first and check the experiment with the speeds a bit. So 1 is really slow. Also, don't forget to set the angular drag to 0 because we don't want friction stopping or slowing us down. So how about 100? And you can see the player flies off. 100 is a bit too much. So how about 15? Let's try 15. And 15 is also very fast, and also you can see that our player is kind of tumbling off into the distance, and if you don't want that, that is because of the friction. So if you don't want that, you can just go to prefabs, create a physics material. It must be here somewhere, physics material, and name this one player mat, and set both the frictions to 0. And now go in the player, and in here in the rigid body, no, as a matter of fact, the box collider, there will be this material which we can reference and drag and drop the player mat in here. Now when we start the game, you can see it doesn't tumble off. That was because of the friction. Now 15 is a little bit too fast for now. Also you can see that the cube goes off into the distance and now we can't even see it. So for that, what we are going to do is we will need to have a camera follower. Now what we could do, we could just place the main camera under the player, but what that will do, that will even take the rotations of the cube with the camera. So for example, if we collide with an object later on in the game, and if we collide, of course our cube is going to tumble off and it will rotate, and so will the camera, and that won't look very nice. So we won't do that. Instead, we are going to create a new script, C# script named camera follow, and drag and drop it in the main camera. So now if you go in the main camera and see the inspector of the main camera, you can see that we have the script. Let's open it up in Visual Studio as default, delete the first two using texts, and also delete these two functions because we are not going to need them in camera follow. So we are going to make three variables in the script. So one transform. Now I said that there are only like strings, integers and all that, but no, there are also transforms. Now what is a transform? In the inspector of every single object you make, there will be a transform, which signifies the position, rotation and scale of the object. So if you want to get the position, rotation or scale of the object, you have to use transform. Yeah, I'm just going to name this something like target. I'm going to make two more variables. So this is going to be a vector 3, and I'm going to name this one. Now what is a vector 3? A vector 3, basically if you're working in 2D, there will be two vectors, which is the x and y. So kind of like axis, but in a different way. So now since we're working in 3D, there will be three vectors, x, y and z. So vector 3, I'm going to name that, let's say, what could I name it? I could name it offset, maybe, yeah. And then public, one more, last variable, public, and smooth speed. This will smooth out the follow of the camera, or else it will just be stuck and it will look really snappy and weird. So you can check that out if you want, and whatever you like you can do. Oh, what am I doing? I didn't even write the type of this. So this is going to be a float since it's a speed, kind of speed. Oh, why didn't I put a semicolon there? And this will be equal to around 1.25, I mean 0.125. Now since if we write this and end this, you will see there is a red line under there, which means there is an error there. Now what is the error? It cannot be converted to float. Now use an F. So to convert it to float, you can just use an F, so it will be converted to float and it will be easier for Unity to understand what we are actually trying to do. Now get to spaces, 2 times enter, and make a public void late update. Now I'm going to tell what this late update does right now. So as you can just hover over it and see, the late update is called every frame if the behavior is enabled. So I'm going to tell what that means in the series next video also. And right here I am going to type in target dot position transform.position form.position is equal to, so target.position plus offset. Now I'm going to tell you what this does in just a second. So just add a semicolon, save it up there, go to Unity and let it load there, and now you will see there are a lot of variables here. So for the target we are just going to, just add the player rigid body, or the transform, sorry, because it's a target, the transform, and then in the offset I'm going to let you know what this does in just a second. So play this, and before playing it just disable the maximize on play so that we can still see the inspector and all of that. So we have started it now, and you can see where the camera is. The camera is there for some reason now. That's because the offset is really off. Now as you can see, if we increase the Z be about that much, around -10 looks good for me. And where did the player go? Oh my god. Okay, so anyway, you can see that this offset, basically where's the main camera, this offset will make it be where the camera will follow it, where the cube will be in the camera's range. So around it should follow like that. Now with this script and this feature, your camera won't rotate when the cube does, so that's a really nice thing. Now that was it for this video. We created 2 scripts, we had some fun with coding, and I'll see you in the next video. Till then, bye bye, thanks for watching, and we are on the road to 60 subscribers, just one more. And thank you all for your support, it means the world to me. Bye bye, see you in the next video. Till then, stay tuned.